Welcome to this lecture number 18 of the course Computational Hydraulics. We are in module 2 numerical methods. In this particular lecture I will be covering unit 14 finite volume method and Godunov approach. A learning objective for this particular unit. At the end of this unit, students will be able to discretize conservation laws using Godunov method. We already know this is our conservative form in terms of phi. F phi is the flux function, S phi is the sourcing term. Let us consider our general from our general case one simple approximation, that is flux can be written in terms of A phi, where A is constant, phi is the scalar variable. Basic structure of Godunov method is with REA algorithm. REA means reconstruct, evolve and average. In this case, we reconstruct a piecewise polynomial from cell average value phi p n as phi tilde, this phi tilde n x t n, that means present time level. This is with the present time level value and where x is local. So, in the next step we evolve the hyperbolic equation with base condition or initial condition to obtain the future time level value tilde n plus 1 tilde n plus 1 and at this level we use our existing knowledge or previous methods to evolve this hyperbolic equation with base condition. Then we in the last stage we take average of the polynomial function at the cell level to obtain cell average value at future time level. So, it has got 3 steps. One is reconstruct, second is evolve and third one is average or taking average of the value. And in this case this phi tilde n x t n or t n, this is subscript or superscript, is constant over time interval t n where t is within n to n plus 1 and within this time interval this tilde phi function is constant. Now, we already know from our Riemann problem that at interface there is discontinuity in information. On the each side we have on the left side we have P cell, and this side we have E cell. So, there is discontinuity in value. Now, at this E phase we can construct Riemann solution. For construction of Riemann solution we can define single variable. So, the flux at cell phase depends on exact solution of this tilde x t of the Riemann problem along the axis, considering along the t axis, considering local coordinates, we have this tilde x t, where in the east phase we have x minus x e t minus t n. That means we are taking this point as a starting point. We have P cell, this is E phase, this is east cell, west cell. At interface we are considering the Riemann problem at E phase and this point only. So, x in this case varies from x p, this is x p, to x e, that means center of the cell E and P, and the time this is again, if this is level n, this is n plus 1. So, time interval will be considered in this case. So, everything varies between this n and n plus 1 time level, and we have defined one single variable. Single variable we can also write it like this, psi x minus x e divided by t minus t n. So, this is only definition for E phase. We can again define another Riemann problem for this phase, considering W and P, that will be bounded between x p, again we need to consider that. So, in terms of local coordinates we can define number of Riemann problems and we can individually solve them to get the values at future time level. So, tilde x t, this is W, again x minus x w divided by t minus t n. So, with this basic knowledge we can start our finite volume discretization. From Riemann problems, this is at W phase. If you have W phase, obviously x will be xw, x equals to xw. So, x equals to xw, this is essentially phi w 0, because we have defined our new variable like that psi. So, this is equal to 0. Similarly, for east face, again this will be 0, this will be 0. So, with that information we can see that the information is travelling from W face and E face either on the right hand side or left hand side through this constant line or any curved line or characteristics line. But the main thing is that within this time interval there should not be intersection of these characteristic lines. So, this should not intersect each other. Now, in this case the basic thing for the Godunov method is that with that approximate tilde value we can approximate our numerical flux. So, numerical flux in this case can be written like this, where this flux function, we know that our original thing was phi n plus 1 equals to phi p n minus delta t by delta x. This was f phi x e t minus f phi x w t without considering the sourcing terms. So, in this case we need to approximate these two derivatives or numerical fluxes. So, numerical fluxes essentially these are average values within the time intervals. Now, if we consider our case here, we already know that phi tilde x e t, this is phi e 0, and at west face we have w 0. We can use these two values directly within our flux function calculation. Obviously, this f phi, this is again written as function of phi tilde e, and f phi tilde x w t. This can be written with this approximation, and for w again we can write like this with this approximation that this is in terms of secondary variable, this is 0. So, essentially this tilde, this thing is not varying within the time period, or so solution is not varying within the that time interval. So, we can directly write it as f phi e 0 and f phi w 0. This is from the basic definition here, that the quantities are not changing within this time interval. Now, if we see our Godunov method, that means we are solving this problem at this interface and waste phase, where left hand side we have W, right hand side we have P cell. For east phase we have E cell and P cell. Again in this case, depending on the nature of the characteristic line which is coming from this point, we need to consider the situation, if it is in the positive side or it is in the negative side. In this case also, if it is on the positive side or in the negative side. Essentially we have converted it to the 0 point and we are calculating the future time level values. Like our previous definition, we have expressed it in terms of A minus A plus. This is essentially our A plus line, this is A plus line, this is A minus line, this is A minus line. That means information is travelling from this phase to the positive side or negative side. Depending on that, we can write it like this. So, this is again solution of the Riemann problem, that the solution at this interface E depends on the cell values on both sides E and P, and if it is A plus, so this will be phi P. If it is negative, then phi E. Again at W interface, if we have A positive, then this is W, and if it is negative, again this phi P n, this is coming because it is a negative one. And the definition like our upwind approach, this is similar. That means for A greater than 0, only A plus will be A, A minus will be 0, and A greater less than 0 will have A positive equals to 0 and A negative equals to A. Now we can see that this is same as upwind approach. So, we have used our approximations, but still we are getting similar results like our upwind method. So, Godunov method in basic form, this is essentially first order upwind approach. Thank you.